Welcome to Boundless Cosmic Tales. In this video, we'll explore some of the most recent space probes and their missions throughout our solar system. We'll look at some of their accomplishments and unfortunate failures. At the end, we'll take a glimpse into the future of some of NASA's exciting upcoming missions. Touching the Sun. Meet NASA's Parker Solar Probe, a mission like no other. It's traveling closer to our star than any spacecraft in history to uncover its deepest secrets. Let's explore this incredible journey. Launched on August 12, 2018, aboard a Delta IV Heavy rocket, the Parker Solar Probe is named after Dr. Eugene Parker, the scientist who first theorized the existence of solar wind. It's the first NASA mission ever named after a living person. To survive the sun's extreme heat and radiation, the probe is equipped with a revolutionary heat shield made of carbon composite materials. This shield allows it to endure temperatures of nearly 2,500 degrees Fahrenheit while keeping its instruments cool. The Parker Solar Probe is venturing into the sun's outer atmosphere, the corona, to study the mysteries of solar wind and the sun's magnetic fields. This can affect everything from Earth's climate to space weather that can disrupt satellites and power grids. Its mission ends in 2025, but already, Parker has made groundbreaking discoveries. It revealed the sun's magnetic fields are more dynamic than we thought, and uncovering more information on the surprising switchbacks in the solar winds. These findings are transforming our understanding of our closest star. Parker's Solar Probe is more than a spacecraft, it's a pioneer, blazing a trail into the most powerful object in our solar system. Its discoveries will help protect our technology and deepen our connection to our home in the Milky Way. Next up is a big one, or a small one. I guess it depends. In any case, let's explore the LISA Pathfinder and its groundbreaking mission to discover interference in spacetime. Yeah, that's right. Spacetime involving tiny ripples caused by events like black hole collisions or neutron star mergers. These massive cosmic events were originally theorized by Einstein, but are extremely difficult to detect. Launched by the European Space Agency in 2015, the mission demonstrated that we could maintain these test masses in near total isolation from external forces, like vibrations and solar radiation, with mind-blowing precision up to nearly a billionth of a foot. And it was such a success that the next mission will involve 3 spacecraft literal millions of miles apart measuring their distance in spacetime to detect any disturbances by things like gravitational waves. This full-fledged mission is so difficult to pull off because it involves micro-measurements from millions of miles apart. It is currently set to happen in the year 2035. The LISA Pathfinder was a small step, but it opened a giant window into understanding the universe. Soon, we'll be able to listen to the cosmic symphony of gravitational waves like never before. Did you know that there are satellites small enough to hold in your hands? Well, one was designed to study the sun. Meet CuSP, the CubeSat for solar particles, a small spacecraft with a big mission to explore space weather and help us understand the sun's impact on Earth. The CuSP was launched on November 16, 2022, as part of NASA's first Artemis mission. It hitched a ride aboard the Space Launch System rocket and was deployed into space as a secondary payload. After deployment, CuSP successfully booted up, stabilized, and deployed its solar panels, orienting itself toward the sun. Its mission? To study the sun's energetic particles and magnetic fields, key drivers of space weather. Space weather refers to the conditions in space, primarily by solar activity, which can disrupt communication systems, damage satellites, and even create currents that threaten power grids. CuSP aims to help by collecting data that could improve space weather forecasting and demonstrate how small, inexpensive satellites could work as part of a larger network. The project could have been a massive help for understanding how solar activity affects us on Earth, but after just 1 hour and 15 minutes, its signal abruptly vanished. Despite extensive investigations, the team was unable to re-establish contact, and CuSP's mission officially ended in December 2023. While the mission was ultimately unsuccessful, it demonstrated the potential of CubeSats for deep space science. These small but powerful satellites could one day form a network to monitor space weather across the solar system, helping us better understand and protect our planet. We know you've probably heard this one, and for good reason. Imagine peering into the universe's origins, capturing light from the first galaxies ever formed. That's the mission of NASA's James Webb Space Telescope, humanity's most advanced eye in the sky. Let's take a closer look at this incredible feat of engineering and the discoveries it's making. It was originally projected to launch way back in 2007, with a simple budget of $1 billion. But that didn't quite happen. By the time it launched in December 2021, the total cost had ballooned to approximately $10 billion. And the delays were primarily attributed to complex engineering issues and the sheer scale of the project. At its launch and deployment, it had over 340 points of failure, meaning if any one single thing went wrong, the entire $10 billion telescope would be useless. Amazingly, it has survived the journey thus far and has already made significant strides in our understanding of the universe. As of November 2024, here are some of its most interesting discoveries. We found a potentially habitable planet only 120 light-years from Earth. It has a similar ocean to Earth and potentially a similar atmosphere, although scientists are still not quite sure of the exact elements they're made of. Recently, Jwst has been looking into the distant past at our oldest galaxies. It has found 5 of the oldest galaxies in the universe, at 13.6 billion years old, that were previously unknown. If these galaxies are verified, they will be older than the previously known oldest galaxy by over 80 million years. And finally, we could be unlocking the secrets of how massive black holes formed in the early universe. Astronomers found a rapidly feeding supermassive black hole in a dwarf galaxy just 1.5 billion years after the Big Bang. This black hole is devouring matter at a rate 40 times faster than previously thought possible, offering a rare glimpse into the extreme growth of black holes in the early cosmos. This discovery sheds light on how supermassive black holes grew so quickly, helping us understand the evolution of galaxies and the universe itself. Now, let's take a quick look at the future and see what exciting probes and telescopes will help us learn more about our solar system. First, we take a look at NASA's Lunar Trailblazer. Its mission aims to uncover the mysteries of water on the Moon. Launching at the beginning of 2025, this small satellite will map the abundance, location, and form of lunar water in unprecedented detail. Using 2 instruments, the HVM-3 spectrometer and LTM imager, it will study water's behavior, whether as ice in permanently shadowed craters or as moving liquid molecules across the lunar surface. Similarly, the upcoming NISAR will study some of Earth's natural processes, measuring the sea level, groundwater, and ice sheet glaciers. Featuring the first radar of its kind in space, it will thoroughly map Earth's surface, detecting changes as small as a centimeter. The NISAR will give us a closer look at some of the complex ecosystem changes and help us further understand natural disasters on Earth. Looking ahead, in 2032, the Geostationary Extended Observations, or GeoXO, is a joint NASA and NOAA program aimed at providing continuous imagery and data on Earth atmosphere, land, and oceans to improve weather forecasts and environmental monitoring. It will enhance capabilities on weather monitoring across the globe, offering advanced imagery, lightning tracking, atmospheric composition data, and ocean health measurements. It will support both short-term weather warnings and long-term climate change planning. The first GeoXO satellite is set to launch in 2032, with the mission running through 2055. This could change how we view our weather in the 2030s. We could potentially get weather forecasts with incredible precision. No more guessing if it's going to rain. So there you have it, a look near and far, from satellites at home to studying the stars. These incredible robots have increased our understanding of our solar system and beyond. And in the coming years, more discoveries will help protect our planet and deepen our connection to the cosmos. Thanks for watching, and don't forget to subscribe for more space exploration stories. And if you like dogs, we discuss lots about our tailed friends, fun facts, and more. Check out our video for some common ways dogs choose to sleep and what it could mean for their well-being.